IBESS, Intro to Resources Part 3, focuses on the dynamic nature of resources across time and space. The significant ideas are the renewability of natural capital has implications for its sustainable use. Secondly, the status and economic value of natural capital is dynamic. Here is the outline of all the available movies for the Intro to Resources unit. Use this outline to find the movie you need for review. This movie is focused here and has a second movie that follows up with the same idea here. Here's the IB syllabus statement that drives this movie forward. The concept of a natural resource is dynamic. The status and market value of natural capital varies regionally and over time and is influenced by cultural, socio-political, economic, environmental, and technological factors. Examples include cork, uranium, and lithium. In explaining the dynamic nature of resources across time and space, here are the factors that influence the dynamism, the status of resources. They're ecological factors, economic, technological, cultural, socio-political, and environmental. Now, this movie is relatively short and examines the ecological influence on the dynamism of resource status. The dynamic nature of resources involves both time and space, the changing abundance of resource across time, and the changing abundance of resource across space. Solar radiation varies by latitude, and the distribution of the Earth's biomes is largely determined by temperature and rainfall. These are gradients that follow the latitude lines. From the equator toward the poles, in both directions, there is a temperature gradient, warm to cold, warm to cold. Natural resource availability will vary according to the gradients that follow latitude. Tropical forests are located here, temperate forests are located here, and coniferous forests here. Hopefully, at this point in this course, you understand that living renewable resources are temperature and water dependent, and temperature and precipitation, rainfall, vary across space. Tropical forests to deserts along a gradient of decreasing precipitation, tropical forests to tundra along a gradient of decreasing temperature. The natural income from living renewable natural capital is the net productivity of the system. The net productivity is the quantity that is potentially harvestable per unit time. Different biomes have different net productivities. Thus, natural capital varies spatially. In terms of living renewable natural capital, tropical forests have greater natural income than deserts. In this photo, we see natural income being harvested from the forest. The forest is the natural capital. This quantity or type of natural income cannot be harvested from deserts or tundra. Wet rice cultivation requires large quantities of rainfall. Wet rice cultivation in significant quantity does not occur outside the tropics. Rice or lumber as forms of natural income are not harvested here in the Death Valley of California. Natural capital has a spatial dynamism. Natural capital varies regionally, thus its market value would also vary. Resource availability varies regionally. This is a photograph of the Okavango Delta in Botswana from space. This region is wet, while this region, just a few tens of kilometers away, is dry. Both the types of living natural capital and the quantity of living natural capital will vary across short distances in this area of Botswana. In the Okavango swamp, there are fisheries, while in the Kalahari Desert, there are antelope to be hunted. Resource availability varies spatially, varies regionally, and the market value of natural income as good will also vary. Some countries like Brazil, Russia, and Canada have a lot of available fresh water. Other countries like Oman, Yemen, and Saudi Arabia have no surface water at all. The market value of water as natural income will vary with its availability. The value of water will vary regionally based on availability. Availability, though, will depend on water's presence as well as the number of people who would withdraw water from the country's surface water, rivers and lakes. Here are some statistics to make this point. Canada has 20% of the world's fresh water, but only 0.5% of the world's population, while China has 21% of the world's population, but only 7% of the world's fresh water. The American Southwest is a desert, so dams have been built along the Colorado River as a technological mechanism to redistribute water to make water more available for agriculture in locations that could otherwise not support agriculture. The value of water in arid regions is very high. Fossil fuel availability, oil specifically, varies regionally, spatially. Some places have oil and some places have very little. The value of fossil fuels in a location will depend on its availability. This is an interesting diagram that distorts the size of the country based on known oil reserves. In terms of oil, you can see the importance of the Middle East with its large reserves of oil. In Southeast Asia, oil reserves are tiny. 9 countries control more than 75% of the world's oil. The presence or absence of oil reserves in a country plays a significant role in the relationships that country has with oil exporting nations. The presence or absence of oil reserves in a country plays a significant role in the politics of a country, with the potential for conflict. Solar voltaic cells, seen in this photograph, transform solar energy into electricity. The energy from solar voltaic cells is a renewable form of energy, but solar energy varies spatially and temporally. Insolation varies across space and time. The equator receives more solar energy than polar regions, and Paris in June receives more solar energy than Paris in December. Light varies spatially and seasonally. Certain locations have dark winters, and other locations have a lot of cloud cover. The forms of renewable solar energy, such as energy from solar voltaic cells, would have different value in different locations. Desert regions might place higher value on solar voltaic electricity than regions with greater cloud cover. This is a midday photograph taken in Norway in the winter. Solar voltaic electricity cells have no value at this time of year. Other forms of energy have high value at this time of year. Wind energy varies regionally and temporally. There are locations where the wind blows more than other locations, and there are times when the wind blows more than other times. When the wind is blowing, electricity from wind turbines would have great value. But when the wind isn't blowing, other forms of energy, such as fossil fuel-generated electricity, would have greater value. Temperature varies by latitude, and due to a tilt in the Earth's rotational axis, temperature varies seasonally as well. Locations with warm temperatures would have high net productivity, but locations with cold temperatures have low productivity. Net productivity is low during cold seasons, so the value of food changes during this time of year, when food for the people in this location would need to be imported. The flow of water in rivers varies across time, as you can see in this graph of the Mississippi River. Flow rates vary, and if flow rates are low, water availability to surrounding communities would be less. Thus, the value of water during those low flow periods would be high. The Yamuna River in New Delhi, India, experiences regular floods and regular periods of drought. The value of water varies across time. The Colorado River experienced high variation in the magnitude of flows over time until the Hoover Dam was built in 1935, and that reduced the variation in flow. In other words, technological change altered water availability. In Intro to Resources Part 3, this movie, I have discussed the dynamic nature of resource availability across space and time based on ecological factors. In Part 4, I will cover the other factors that create the dynamism and the availability of natural income from natural capital, thus influencing the value of resources across space and time. And that brings us to the end of IB ESS Introduction to Resources, Part 3.